Hello everyone, in this video I will show you our new product. You can see this is Kinkoney F32. So it's very big and it's very powerful because it has 32 channel OMRON 16 ampere relay, high quality relay. It's removable. If the relay is broken, you can replace by yourself. It's very easy. And this board also made by ESP32S3 and support Arduino IDE, support Home Assistant used by ESP Home and supported by KCSV3. Also supported voice controlled by Alexa Speak and Google Home Speak because it is supported by Tuya mobile phone application. So in this video, we will look at this hardware design details and how it works with a different software solution. Okay, let's look at this hardware details firstly. Okay, let's look at this is Kinkoney F32. So it's very big and we can compare with another controller. And you can see this is Kinkoney F16, this 16 channel relay board. You can see the size is big, and this size, let's look at. The size of the lens, you can see, this is the size of the lens. And it also supports install on the DIN rail, no problem. On the DIN rail, and this is size. You can see this is size, and also you can see this size. Okay. So let's look at this interface in description, and you can see this relay output. This is 32 channel relay output. And every relay that have COM and knob open just for 6 ampere max current for this terminal. And this is a relay manual control button. Also used as before if the software is feature and the network is feature. So this manual control button without anything software, just by physically controlling relays coin. And this terminal also is removable. You can see I have removed this socket, so this is removable. It's very easy for you to connect with the one. You can see this is removable. And let's look at this Ethernet part. And this antenna, extend antenna, you can connect with this antenna or connect extend antenna for long distance. So this is for Tuya Wi-Fi antenna, and this is for ESP32S3 Wi-Fi antenna, and this you can see this is download button, and this is ESP32 reset button, and this is for USB-C for download the firmware for ESP32, and SD card will save the logo, and this have a 433 MHz or RF receiver module. You can connect it here, just used by this module. You can see, used by this module, you can connect as this socket so that you can use RF remote or RF sensor. And this one you can see that have free GPL. This 1, 2, 3, 4, 5, 6, 7. 7 free GPL you can use for sensor or for other device. And this for analog input for A1 and A2 is for 0 to 5 watt, and A3 and A4 is for 20 milliampere. And this RS45 A and B, and this is for power. And because the F32 have two versions, one is 12 watt power supply and another is 24 watt power supply. So you can choose which wattage of the board according to your requirements. Just the relay is two different coin voltage. And this one you can see that the digital input. This is digital input. Also used for long distance. This digital input of the cable marks support 500 meter long distance we have designed. So this is all interface at here. And let's open this aluminum shell and look at what is inside of the PCB board. And we will open this screw firstly. And open this one. On this cover, aluminum shell, and let's look at So OLED display and power LED, and the LED indicates for every relay. Okay. Then we can install back of this cover. Okay, you can see this another PCB board. This I'm under testing. You can see this is just a removable relay. So if you want this board to work with 12 volt, just plug in the 12 volt relay. If you want the board to work with 24 volt, you can replace the relay for this 24 volt relay. So the PCB board always see just only the difference of the power supply according to the relay power of the work voltage. Okay, now I will power on and connect with the network, Ethernet, and show you how it works with a different software application. And we can install this antenna because I'm using for TUYA application for testing. And this is the power supply. This I have connected 12 volt. Also you can connect with the 24 volt if you choose this board support 24. And I have already downloaded the KCS V3 firmware, and I just power on of this board. You can see power on, and this the green LED is on, and that will show the welcome information, and we will see the Ethernet IP address and the Wi-Fi IP address. So this is Ethernet IP address, so we will log in my computer. Okay, let's back to my computer, and you can see in our official web page that shows the F32. You can see some details, input and output, and some related information. You can see the ESP32 IO pin define and the ESP home YAML file and Arduino source code. You can see this all have showed in our form that you can see it here. Just go into this F32 and you will see many results at here, source code and ESP32 pin define and ESP home. And let's look at KCS. We can log in by our web browser, use the Ethernet IP address and the default username and admin and the password admin. And you can see this is F32 and this is the version, and this is set for the input. If you want to reverse the level, you can click it here. And this is output for setting. And this have IF. You can learn signal from IF sensor or IF remote and use a binary sensor. And this is sensor. You can add a sensor, choose some different types of sensor that by different bus. You can see this one-wire bus, and this I2C bus, and this IS485 bus. So you can choose by yourself. And max support 32 sensors by one controller. And also support one GPIO, such as you can choose DS18B20 temperature sensor and use by one GPIO for multi sensors. Okay, and let's look at the monitor. You can see I have connected the King Kong Cloud and the Home Assistant by MQTT Auto Discover, and the TUYA also is connected, and some other protocol. If you want, you can see it here. You can enable which one to use the protocols, and you can see I have enabled the King Kong Cloud. So you can see in King Kong Cloud dashboard, this is by internet, remote control by internet. You can use any computer. You can see F32, click, and you can see the switch and digital input and analog input. You can see I can turn on relay 1 and turn on relay 2. So you can see this relay 1 and relay 2 is on. And I can also turn off relay 2 and turn off relay 1. This is for King Kong Cloud. And this one is for Home Assistant Auto Discovery. So you just import the device name and the Home Assistant Mosquito MQTT block IP address and the port and the username and the password. So all the results of F32 will update to Home Assistant. Let's look at the Home Assistant dashboard. I have do nothing set for Home Assistant. So just it will have auto discovered at this device, and we can import F32. You can see it here. And F32, you can see 32 channel switch and 4 channel analog input and 32 channel digital input. And if you have connected with the sensor, temperature sensor and humidity sensor, also we update to Home Assistant. And you can see I can turn on this by Home Assistant. You can see this relay will on. So there are 0 code set in Home Assistant. And also you can see I can back to the monitor. You can see the monitor, you can see this have turned on, and I can turn all off, and turn all on, and all off, and all on. If I turn all on really on, you can see in Home Assistant that is all on. So this is update the state, and also we can look at this one, Kinkoni Cloud Server, also update the state. So this can use any application and make sure they update the state. Or is no problem for different application. Okay, so this is for digital output, and you can also trigger by digital input use binary sensor. This also you can use in Home Assistant. And let's look at this FTDT. If you want digital input and work with digital output, such as connect with a switch button, so you can edit your FTDT, use DI, which DI, and trigger which DO. So this is flexible. You can use any digital input, work with any digital output just by FTDT. And the next you can see that is for the network setting. And if you have Kinkoni G1, so that you can use a GSM module, so that you can use short message or voice call to turn on and turn off relay. So it also is supported by FTDT used by 4G and for SMS notification. And the next you can see the protocol I have showed you before. You can see the UDP and the TCP and HTTP and MQTT all will be supported. And this is customer side protocol used for FTDT. And this is also supported by Apple HomeKit. So you can set input and output and digital and DAC, that is know this resource, so this not found. And ADC, that for analog, just use work as a sensor in Apple HomeKit. And at last, you just enable the Apple HomeKit and this code to add to your iPhone or iPad. Okay, you can see this is Loxan system. The Loxan also can be supported by UDP command. You just set here. And this is protocol, how to integrate to Loxan mini server. So this can be used. And we have many demo how to integrate to Loxan system in our form. So you can see some video talk about it. And this is WS2812. That is for LD strip, the RGB LD strip, which GPL you have connected. So you can just set here. And the LD account, you can change it here. You just enable this. So you can connect many LD strip, RGB LD strip in this F32 free GPL. And the last, you can see the system. You can set the time and the time room, and set the double click and single click the time you want it. And this is restart the board, and this is restart manufacturing setting by this button. So this have should work with the KCSV firmware. If you want to use your own firmware, you can write your Arduino source code, and also you can configure by ESP Home. You can see our form. You can see this is ESP Home YAML file. So you can use this code and configure by yourself and what you want. This also is flexible. And all Kinkoni product support ESP Home and support MQTT. So that will be very easy to integrate to other platforms. Okay, this is F32. If you have any questions, you can leave a message to us. Thanks for watching.